Let's talk about temperature. We're going to talk about what it is, how we measure it, and how we convert between different temperature units. First of all, if you ask the average person on the street, what does temperature measure? They're going to say heat. It does not measure heat. Heat is measured in a unit called the joule, which is actually a generalized SI unit, metric unit, for energy. Heat's a kind of energy. Heat can't be measured with a thermometer. As a matter of fact, there isn't an instrument that can measure heat directly. You have to actually move the heat from one place to another in order to measure it. We'll talk about that later on in the year when we get into thermodynamics. Temperature is actually a measurement of something called kinetic energy. It measures the average kinetic energy of a sample of matter. So what is kinetic energy? Kinetic energy is the energy of motion. Particles in matter are constantly in motion. Whether it's a solid, a liquid, or a gas, all particles are always moving in matter. And so when you place a thermometer into a sample of air, for example, or liquid or solid, what you're measuring is the movement of those particles. So how are you measuring the movement of those particles? Well, as it happens, when you place a thermometer into some, and we're talking about like a mercury thermometer, into a sample, those particles of the sample which are moving are going to collide with that particular thermometer, and they're going to transfer their energy to the mercury inside. Now, if the mercury is cooler, the particles will be closer together because matter generally will expand or contract based on its temperature. If you add energy to that mercury, though, those particles start to vibrate more and more and more, and they spread out, and so they'll climb up inside the thermometer. And that's sort of how it registers, okay? There are three main temperature scales. Two of them you probably heard of. As a matter of fact, I would bet that you use Fahrenheit all the time. The Fahrenheit scale was created in 1724 by Daniel Gabriel Fahrenheit. It's only used in the United States. It's pretty much only used here. Nowhere else in the world uses the Fahrenheit scale, and nobody in science uses Fahrenheit. The Fahrenheit scale was set up around some less than precise values. It's been refined over time, but it's just not very useful in science. You don't use it. You've probably also heard of the Celsius scale, which is sometimes called the centigrade scale. Centigrade literally means 100 degrees. This was created by a physicist by the name of Anders Celsius, 1742. It is set up around the freezing point and the boiling point of water. Freezing point being 0, boiling point being 100 degrees centigrade. And in the 1940s, it was renamed the Celsius scale in honor of his work. It's used everywhere else in the world. It's used in some cases in the United States, but I mean everywhere else for all temperatures are pretty much measured in Celsius, and we use it in science all the time. The third temperature scale you may or may not have heard of, but it's called the thermodynamic temperature scale, or the Kelvin scale. And this was a scale that was developed by William Thomson, who was knighted Lord Kelvin. And in about 1848, he was looking at understanding the idea of the motion of particles. And he defined, well, at 0 degrees, there should be no motion of particles. He called that absolute zero. It corresponds to a Celsius temperature of minus 273.16 degrees. It's really cold. It's also a theoretical temperature, which means it's impossible to reach with our current technology and with the laws of physics. You can't actually get something to absolute zero. But the Kelvin scale is the standard unit for measuring thermodynamic temperature. And there's a reason why it's used more than the Celsius scale when we're talking about thermodynamic temperature. We'll talk about it in just a second. So here's an example of some common temperatures that you should know. I don't really care if you know the Fahrenheit scale, these values, but you should definitely know the Celsius scale and the Kelvin scale. Water boils, Celsius, 100 degrees. You should know that. It freezes at 0 degrees, and normal human body temperature, average human body temperature, is 37 degrees Celsius, which corresponds to 98.6 Fahrenheit. Okay? But you should know, 37 degrees. On the Kelvin scale, those values are different. Okay? Water boils at 373 kelvins. It freezes at 273 kelvins. And average body temperature is 310 kelvins. Okay? These are some values that are good to know. But also, they help us set up how we convert between Celsius and Kelvin. And it's really simple. If you just look at the boiling point and the freezing point, you'll kind of get a sense of how that works. So first of all, I want you to know these things. Water boils at 100 degrees Celsius, freezes at 0 degrees Celsius. If you go below 0 degrees, which you can, you'll have a negative temperature. Well, negative just means below 0, but really if you're measuring motion of particles, there's no such thing as negative motion. You either have motion or you don't. So on the Kelvin scale, water boils at 373. It freezes at 273 kelvins. And if you go down to 0, which is the coldest temperature theoretically possible, you have 0 kelvins, no motion. There are no negative numbers in the Kelvin scale. That's really going to be important in a future unit when we talk about the kinetic molecular theory. Okay? So if you want to convert between Celsius and Kelvin, all you have to do is add 273 to your Celsius temperature. 0 plus 273 is 273, and that's the Kelvin temperature. And if you want to go from Kelvin to Celsius, just subtract 273. 1 degree Celsius and 1 Kelvin are the same amount of measurement, but they really have two different meanings, right? Kinetic energy for kelvins and Celsius is really, we're just looking at the temperature relative to, say, water.